Hello, we are live. Let's just give it a few minutes for people to join in, and I'm gonna share the link on my social media channels. Let's have a look here. Okay, that part is done. Alright, I'm just gonna chill here for a moment and wait for people to join in. So I'd like to explain the whole scenario once and maybe a couple of times as we go along. But let's just delay that a little bit so people can find their way to the channel before I have to repeat this whole thing many times. In the meantime, let me have a look at these links here. I will be referencing this document to begin with. Okay. Alright, if anyone's watching yet, feel free to say something in chat and let me know if you can hear me or if there's anything wrong with the audio, and if you can share or if you can see my screen. I think everything should be good, but since I can't hear myself, I've muted all my audio so there won't be any echo and the audio doesn't circulate. I can't tell. Okay, I get a thumbs up here, so it seems like everything is good. We'll just hang in here for a couple of more moments before we get started. I'm just gonna open my topology page. Yeah, I'm gonna start at 5 past, so let's give it a minute or so before we get going. Okay, so it's 5 past now. We can get started. So a couple of notes before I get into the topics. So this is a study session. This is not a lecture. So I haven't planned this content beforehand and I don't really have a clear agenda. So we're just gonna see where this goes. I did plan a couple of topics beforehand. So we're going to discuss basic routing principles and route selection in Cisco routers. Yeah, feel free to ask questions and interact with me in chat. So this is not a monologue from myself to the webcam. So yeah, I'm hoping to get some engagement from you guys. I'm using my Eve NG Lab for this session, this very simple topology of 5 routers, and they're all looped together. Actually, I don't think R5 is still configured because I kind of added it when I was testing something else. So in case we want to do something with that, that is blank. The other routers have been configured with basic IP addressing and OSPF as well. I can show you on R1. I already looked at it briefly. Oh, it's timed out. So let me do that again. So show IP interface brief. So we have some IP addressing configured here. And then you can, if we look at the routing table, you can see that there are some OSPF routes. And actually I can see that there's also inter-area routes. So that means I've configured multiple areas in this topology. So it's not only area 0 or the backbone area. I actually don't remember exactly what I've put in here because I've had this topology for a while and I've used it to test different things. It doesn't really matter for now, and we can change that if we do anything related to that. What else did I want to see? Show IP OSPF neighbors. Yeah, as you can see, there's only R2, so R5 is not configured. But again, it doesn't matter at this point. So the logic for the IP addressing is the base network is 10.10.0.0, or I should say like x.0. So the third octet here kind of signifies, or it's like a combination of the router IDs or the router numbers. So R1 and R2, that's why it's 12, R2 and 3, that's why it's 23, and so on. So it's easy to identify the networks when we look at the routing table. And then all routers also have this loopback address configured, which we'll use as the router ID as well. So yeah, that's just a quick explanation of the topology. So I guess we can jump to the topics now. Any questions so far? My other monitor is on my right hand side here, so if you see me looking that way all the time, it's because I'm trying to like watch for the comments as well. I see nothing so far, so let's go to this document. This is the one I'll be using for now. I can actually put this link in the in the description or in chat, so you guys can get it as well. There you go, if you want to follow along with this document. I have zoomed in a little bit, so hopefully the text is clear. Alright, so let's look at route selection in Cisco routers. I've referenced this document many times, by the way. I really like this document. I feel like it explains the basic principles pretty clearly. But essentially, let me scroll down to the part. Processes involved. So we have various routing processes, the routing table itself, and the forwarding process. I don't really want to talk about that just yet. Maybe we can look at this section, building the routing table. So there's essentially 3 components involved in that process. And now I'm thinking how I should describe it so it's the most logical way. because these all three components, so the administrative distance, the metric, and the prefix length, all kind of do a different thing. Okay, I'm going to start with the prefix length, and then we'll come back to the administrative distance and the metric after that. So let's just establish the meaning of the prefix length first. So let's actually read through what it says here and then talk about it in more detail. So as each routing process receives updates and other information, it chooses the best path to any given destination and attempts to install this path into the routing table. For instance, if EIGRP learns of a path toward 10.1.1.0/24 and decides this particular path is the best EIGRP path to this destination, it tries to install the path it has learned into the routing table. The router decides whether or not to install the routes presented by the routing processes based on the administrative distance of the route in question. Actually, this talks about something else that I wanted to bring up. I thought it would focus on the prefix length, but this is actually describing more of the whole process, or like summarizing how these three components work together. So let me actually backtrack. And again, as you can see, this is not planned, so if I had looked at this document beforehand, I wouldn't have read this just now. So let me try to wing it explaining the prefix length. First of all, by default, routing is destination IP based. Now, what comes to the prefix length, so each, how can I say, unique network address and subnet combination is its own route. So you can have routes that overlap in the routing table, but they are still considered separate routes. So then, how is the packet forwarded if there are multiple routes that could be chosen? Well, this is where the prefix length comes in, because the most specific route is selected, or the match with the longest prefix length. So maybe let me try to demonstrate that on the topology here. So let's just maybe come up with some routes. Let me draw it here, and I'll try not to mess it up this time, because there are these two buttons on my pen tool, and whenever I press them, it kind of locks the drawing function, and then whenever I move the pen, it just keeps drawing on screen. So I'm hoping that's not going to happen. Okay, so what I mean is, let's say on R1 we have routes, and we can actually configure this as well. We can add some static routes. But let's say we have network 192.168, and that is horrible. Let's go back. So 168.1.0/24. And then we have two other routes. So 192.168.1.0/25 and 192.168.1 and then excuse me, I meant to write something else. So 128 and /25. So now the two bottom routes right here, the /25s, these are fully covered by the first route. However, these are still considered unique routes, and if I configure these as static routes, for example, on R1, these should all be added to the routing table. And we can actually try that. We can configure a static route pointing to the null zero interface. We don't have any traffic coming to those IP addresses, and those IP addresses don't exist anywhere, but we don't really need it for the demonstration here. So let's actually try that. We can go on R1, and if we add static routes, so IP route 192.168.0 and then /24 mask, and let me see here. Yes, null. Okay, let's just look at the routing table real quick. Do show IP route, and actually let's do it this way, static, so we can see only the static route. So you can see that's right there now, what we just configured. So now if I add 2 more routes, as I just drawn them on the topology, so let's change this a little bit. So /25 mask is equal to 255.255.255.128 subnet mask. And then let's add the other one as well. Okay, so now if we look at the routing table again, you see that all those routes were installed into the routing table. We can exit out from the config mode. So once again, even if these 2 routes are fully covered by the primary route or the less specific route, they are still all installed into the routing table. Any questions so far? Oh, null zero stands for, this is just like a disregard interface. So this is like the bit bucket. So these packets pointing to this interface, they're just dropped. They're not sent anywhere. So this is like a good way to test something. If you don't want the packets to be forwarded anywhere, you can point them to the null zero interface. Okay, so if I go back to my drawing, or I don't actually even, yeah, let me do it that way, because I don't think I deleted this. So now if we come back to the prefix length, so if we have a packet, let's say 192.168.1.7, come to the router. So R1 receives this packet. How would it forward that packet based on these routes? What do you think? Any thoughts? This is a little bit silly question in this case, because all of these routes are pointing to the null zero interface. So, you know, they would still go to the same place and they would be disregarded at this scenario. But those routes could be pointing to different interfaces or different next hops. But I want you to understand how the router would select the route, that how it would forward this packet in case this was a real scenario. Yes, exactly. It would prefer the /25 routes because they are more specific. So this is where the prefix length comes in. So that is essentially how the forwarding path is selected. So because of this address that I selected right here, it would actually choose this one. And in another instance, so let's say we would have another packet, 192.168.1.7, 1 dot, let's say 142. So with the same logic, this one would be forwarded according to this route. So that's the prefix length. So the prefix length really defines which route the router selects to forward that packet. Let me delete this. So if I go back to this document, that's kind of why I wanted to explain it first, because in my opinion, this is more about route selection or path selection for forwarding packets and not so much building the routing table. Although, if you have learned the same exact route from different routing protocols, then it comes into play, because only one of those will be selected and installed into the routing table, and that's where the metric and administrative distance comes in. So we're going to look at that next. But let me explain that as well. So let's say the pen tool first. So let's say that R2 is advertising this route to R1. Okay, what happened there? And it is advertising it using both OSPF and EIGRP. So then R1 would select one of those routes to be installed into the routing table, because it's the same exact route, because it's the /24 mask and the network address is 192.168.1.0. However, okay, let me see, how can I draw this? So if it advertised the other two routes, so let's say 192.168.1.0/25, and this was advertised from OSPF, and then the other one 168.1.128/25, and this was advertised via EIGRP. Now in this case, both of these routes would be installed into the routing table, because, oh, excuse me, I didn't mean to close it, because this one was advertised via OSPF and this one was advertised via EIGRP. So different routing protocols, different routes, and more specifically because they are unique routes, they would both be installed into the routing table. I'm thinking if we could actually try to look at this scenario as well. Let me see, how can I configure this so you could see it on R1. Okay, we would have to like add EIGRP configuration to R2, and then if we would do some kind of redistribution, we could add those routes as we have configured on R1, but move them to R2 and then configure redistribution, for example. Yeah, we could do it that way. Let me see. For redistribution, and if let me have a look here. Okay, let's go back to R1 first. So shall run here are the routes that we just configured, and let me take out this as well. Oh, this is from my last session. So we'll do a new tab. Okay. Let's actually move them from here first. So conf t. Oh, I didn't mean to press enter. Right, let's delete all of this. Invalid input detected? Why? Oh, I know why. I didn't copy the IP route part. I just copied route and not IP. Okay. Okay, so now those are gone. Let's just verify that. Show IP route static. Yeah, we have nothing here now. Okay. Let's open R2. Let me just verify. Do show IP. Interface, brief. Let's see what we got here. Okay. So let me put these static routes here now, and then we can redistribute them into OSPF and see what happens. And then we'll add EIGRP. So this is already getting a bit complicated right off the bat. No, this one. Okay, here we go. So let's have a look here. Show IP route static. Okay, so these routes have been added here. Now, I do show IP protocols. I can't remember what OSPF process ID I've configured on this router. Seems to be 1. So router OSPF 1. So we can do redistribute static, and let's see, we need to define a metric for it as well. Actually, let's maybe do it this way. I'm pretty sure it's not going to advertise this now. I think you need the seed metric. So let's see, show IP route OSPF. Oh, they are actually advertised. I thought you needed a metric defined before those would be advertised. Anyway, route redistribution is a topic for another video. We don't need to worry about that too much for now. Oh, sorry, let me go back to this one. Okay, so you can see now that all of those routes are learned via OSPF as external routes because they were redistributed into OSPF. So now, let's have a look here. Okay, I think Alexa wants to say something. Alexa.
Something, but I'm always working on how I say things, and I might
Alexa,
not have it right.
Stop. I need to unplug her. Anything going on in chat? Oh yes, you noticed my error. Sorry, I'm seeing your message just now. That is used by routers to avoid control plane loops. What do you mean? What is used to avoid control plane loops? Yeah, so this is gonna get a little bit complicated if I want to demonstrate that, what I mean there. So if we want to configure EIGRP as well, we can do that. And actually that, depending on how I enable it, that's probably going to mess up the routing table as we see it now, because there are these other networks as well. So if you see something crazy in the routing table after I start configuring things, don't worry about it now. We'll try to explain it later on as we move further with the topics. Yeah, this is a little bit messy, so hopefully you can follow along. Let me know if you have any questions. Hello there. I see more people joining the stream. Thank you for joining the session, and hopefully you'll learn something new today, or at least refresh your knowledge of these topics. Okay, anyway, back to configuring EIGRP. Let's just add it at this point, and then we can try to make those other topics clear as well. So let's see, let's do router EIGRP 1. Do I even remember how to configure this? Let's say, so we want to enable it between R1 and R2. So network 10.10.12.0, and then the wildcard mask. Okay. Let's do it here as well. Router EIGRP. See if we get a log message. Yep. Okay, so now what I want to demonstrate. Let me close this for a second and let me just verify. Show IP EIGRP neighbor. Let's see. And I don't think we're advertising any EIGRP routes at this point because we only enabled it on the directly connected link. Yeah, no, we only have the OSPF routes here now. Show IP route. Okay. And actually, before I split the route advertisements as I described here, so if we advertise these two networks from different routing protocols, what is this line here? So let me just redistribute those static routes into EIGRP as well, so you're gonna see something else happen. And I'm gonna go back to the explanation in a moment. So conf t redistribute static. So let's see what we find out on R1. Show IP route. And actually, let me see here. conf t router EIGRP1. I'm pretty sure here we do need the metric for redistributed routes. And if I can only remember how to do that, redistribute static metric I will just use random numbers here. So, oops. This is another thing we can come back to. That doesn't matter at this point. I just need a metric for these routes. Let's see if we can find out anything else here now. Show IP EIGRP topology. So you see that these routes are actually, they are learned infinity. I may have done something wrong here. Metric. Let me have a look here. I don't remember all the details of route redistribution, so I may have used values that have caused the EIGRP metric to go into infinity, which means that these are not valid routes and therefore they're not eligible to be installed into the routing table. But let's have a look here again. What values do we want? Metric. So bandwidth in kilobits per second. Let's try something else. Now let's say 10, 255, 1, and EIGRP MTU. Okay, let's try that again. See if it made any difference here. No, it still says that this is infinity. Hold on. Let's do clear IP EIGRP 1. Nope. Neighbors. I did not want it to get this complicated. No, we're still learning it as it says infinity. I don't know why. Chat, any ideas? This is interesting. I was not expecting that to happen. Then if I can't get it to work that way, I might have to try another option. I'm thinking what to do here and how to try out the scenario in a different way. Yeah, show IP route. Okay, let me remove the redistribution for now. So let's see here, do show run, and wherever my character is, I always forget with this keyboard layout. Okay, whatever, do show run, I can't find the pipe character. Yeah, okay, so it was completely removed, that's good. So let me try it this way. I don't know if this is going to work. Let's try with the network command. So if we try to advertise the bottom static route there, 1.128. Discontiguous mask is not supported. Okay. Discontiguous mask. Okay, so let me try it the other way. Let's just advertise the main route then. Actually, that's not what I wanted to do. I did not want it to get this complicated. Okay, let's see what's here now. Why are we still have these here? Clear IP route. Let's just remove everything. Where's the star command now? Oh. This is another thing. Why weren't these cleared already? Might have to start a Wireshark packet capture because there's something I'm not understanding right now. Okay, clear IP, IGRP, neighbors. I don't know why we are still learning those. And actually, look at this. I removed the redistribute command, but somehow now these were feasible routes. What? Is my lab experiencing some delays here? I really don't understand what's happening right now. Have I done something strange? Show run. Okay, I found the pipe command section router EIGRP. Yes, and then OSPF here. I need to check the configuration now. This seems too strange. Okay, so let's look at the same on R2. No. Okay, so the redistribution is gone. There's two network commands. And then for OSPF, okay, so the redistribute command is still there. And actually it has automatically added the subnets keyword. I did not do this, as far as I can remember. So why do we still have these routes learned via EIGRP when I even cleared the neighbors just here? What is happening here? I don't understand. How can these routes still be here? And as you can see, now they're even in the routing table, and they've replaced the OSPF routes. Excuse me. Anyone have any ideas? This, I don't know, this lab is a complete mess now. This does not work at all how I wanted it to. And this is just messing with my head. Show IP EIGRP topology. I truly do not know why it is learning them now when we are not advertising them from here. You see that the redistribution is gone. Show IP EIGRP topology. Yeah, why are they here? I don't get it. I'll just give you a few moments in case you want to comment anything. I need some help here because this does not make any sense to me. Actually, let me show IP protocols. Let me see the line that I'm looking for. Okay, well here, routing protocol is OSPF. So you can see that we're redistributing external routes from static routes, and it includes subnets. Do we have anything similar under EIGRP? I don't think so. So once again, I don't know why the lab is behaving this way. Might be exactly because of that, because this is a lab environment and this is emulated software, so it might not work exactly like real Cisco iOS. But this is certainly interesting. Okay, so one more time. We have no redistribution configured. Somehow these static routes are still in the EIGRP topology table. The routes are learned here on R1, and now they are valid. Before the metric was infinity and they were invalid routes or ineligible to be installed into the routing table, but now they're here with a good metric, and they're even in the routing table, and they've replaced the OSPF routes. Okay, let me try that clear IP HRP neighbors command one more time to see what happens. So clear IP HRP neighbors. Okay, so the adjacency has gone down and it's come back up again. So let's see what the situation is now. So the topology table, it still includes the redistributed static routes. No. Okay, this is the funniest thing. I'm just going to remove EIGRP from the configuration right now because this is not how it's supposed to work. This does not make any sense. I do not know what's going on here, so let's just remove EIGRP entirely. Unless anyone has any suggestions in the comments. Yes, clear EIGRP on R2 and try to advertise it again. Yeah, this is what I have just done and it didn't fix the problem. So the EIGRP adjacency was cleared on both routers. So first I did it on R1, wherever it was, somewhere up here. I think here, yes. So first it was performed on R1. That didn't change the result, and then just now I've done it on R2 here. And still, we're getting the same output. So I'm just going to remove EIGRP. Let's maybe start again or do something else. Okay, conf t no router EIGRP on. let's see if we're still learning EIGRP routes. Okay, show IP EIGRP neighbor first of all. Okay, there's nothing. Show IP EIGRP neighbor. How about the topology table? Okay, there's nothing now. And shouldn't be anything in the routing table either. Show IP route. Okay, at least this is working how it's supposed to right now. Yeah, okay, so there's nothing right now. Let's just verify everything. Okay, now this one is showing only OSPF as well. Yeah. Okay, I have never seen that happen before. I do not know what's going on in this lab. If you have any clue, any ideas, any suggestions, feel free to add in the comments. Okay, well that threw off my plan. And yeah, this is actually a good lesson because clearly this environment is not behaving as it's supposed to. So when you're working with a virtualized environment or an emulated environment, you have to be aware of this. Like you can see behavior that's not supposed to happen. I've had that happen a couple of times before. Actually, the most recent one that I remember was with OSPF, and it was something to do with the default route advertisement and not so stubby areas. I'm not going to go into the details about that, and honestly I don't even remember exactly what the issue was, but I just know that my lab didn't perform as it was supposed to. And my friend Elvin Arias, he was actually using GNS3 for the same lab. We had the exact same setup, the same configuration, and we saw different behavior. So yeah, but it wasn't as striking as this, what just happened here. But that's something to keep in mind when you're working with virtualized environments. Like this can happen. Okay, let's see, how can we get back on track now? Because we've just gone astray from the original plan. So let me just look at the topology again and see what we can do here. Now I don't really trust that EIGRP is going to work in this lab how I want it to, or at least redistribution. I'm scared to do that again. So we might not want to use it for this lab. So I'm trying to figure out how else I can demonstrate the concepts here. Let me see if there's more comments. Have you removed IP route null from R1? Good question. I thought I removed the static routes, but excellent point. Very valid point. So let's double check that. Show IP route static. I thought I removed them here, but yes, I did. That's an excellent point because if I still had those static routes configured here, so they would be more preferred than the EIGRP routes or OSPF routes, and hence they would not be installed into the routing table. So it's definitely good to check that. Yeah, but that was not the issue here. I don't know, it could be otherwise with the null zero interface that it's messing up the lab somehow. I don't know. I'm just making wild guesses here because that was truly confusing. It's like I lost brain cells right there. Okay, so let's try to get back on track. Let me see how we can pick up where we left off. Because we were talking about the prefix length. Let me see, I think I still have the drawing here, which I might have to throw in the garbage right now. So yeah, this is what I wanted to demonstrate, that if you have the same prefix, the exact same prefix is learned from two different routing protocols, then only one of them, the best one, will be installed into the routing table. But if you have those two separate routes, or those last 25 routes that are unique on their own, then those could be advertised separately. So one could be advertised via OSPF and one could be advertised via EIGRP. But since the configuration did not work, I'm not gonna demonstrate that. And we will just erase it and forget that that happened, okay? So bye-bye. Okay, so let me see how we can continue with this. I guess we can go back to this document and discuss the administrative distance and the metric. So let's actually read the descriptions for each of those items first. So from the document, administrative distance. This is the measure of trustworthiness of the source of the route. If a router learns about a destination from more than one routing protocol, administrative distance is compared and the preference is given to the routes with lower administrative distance. In other words, it is the believability of the source of the route. And then metric. This is a measure used by the routing protocol to calculate the best path to a given destination. If it learns multiple paths to the same destination. Wait, I read that weirdly. Now it didn't make sense in my head. So let's see again. So this is a measure used by the routing protocol to calculate the best path to a given destination if it learns multiple paths to the same destination. Each routing protocol uses a different metric. Okay. Maybe I can talk about the administrative distance first, because we kind of saw that in the last mess we were dealing with. So if I go back to R1 and let's see here. Where was the routing table? Let's go way back a little bit more. So you see here, originally, these static routes, when they were redistributed, they were learned by OSPF and installed as OSPF external routes. But then, somehow, when the EIGRP redistribution worked, when it shouldn't have, so those routes were actually installed as EIGRP routes, which are marked here with the D, this code. Don't ask me why it's D. You can see it here. The D signifies EIGRP. I don't know where that came from. Actually, if you have an idea why the code for EIGRP is D, let me know in the comments. This one makes sense for OSPF, so it's O. O for OSPF. Why can't I highlight that? There we go. So let's see those codes here as well. So O, OSPF, is for intra-area OSPF routes, and then O with IA is OSPF inter-area routes. We see those here as well. So OSPF routes learned from other OSPF areas. And then, yeah, this is for NSSA, external routes, this N1 and N2. And then E1 and E2 are for OSPF external routes. Yeah, just a little bit of knowledge there. So yeah, anyway, back to the administrative distance. So once again, previously they were OSPF routes, and then here, somehow magically, they were EIGRP routes. Now, why is that? Well, this is exactly because of administrative distance. So EIGRP routes are considered more reliable than OSPF routes by default. And this comes down to the administrative distance value. So if I go back to the document here, so there's actually this table that lists the default administrative distance values. So you can see here EIGRP, which is also highlighted, I guess because it's a Cisco protocol. So there's maybe a little bit of bias towards EIGRP over OSPF. So EIGRP has an administrative distance of 90 and OSPF has a administrative distance of 110 by default. And actually, now that I think about this again, EIGRP external, I had forgot about this. So the administrative distance for EIGRP external routes is 170, which means it's higher than for OSPF. So these routes would be less preferred over OSPF routes. So actually, I might have figured out what the problem was just there. So, well, actually, it doesn't explain the entire problem. I don't know why the routes were still advertised even though the entire command was removed and the neighbors were cleared. But those should be EIGRP external routes because they were redistributed into EIGRP. So they would have an administrative distance of 170. So they would be less reliable than the OSPF routes. So the OSPF routes would actually be preferred. This is why I need to refresh my knowledge about route redistribution and EIGRP actually as well, because I totally forgot about this. So that certainly explains some aspect of the issue that we just seen there. Yes, so yes, the administrative distance is like signifies the trustworthiness of the route. So if you learn the exact same route from two different routing protocols or two different sources, then the administrative distance value defines which one is the best route or which one is the preferred route. And a lower value is more preferred. So you can see here a connected route is the most preferred and it has a default administrative distance of 0. A static route, which we also configured, they would have a administrative distance of 1. So also very reliable. You can actually change the administrative distance. I don't know if we should try that. I'm thinking if we want to try that crazy redistribution scenario again, but if we reconfigure the administrative distance value and make it lower than the OSPF administrative distance. I wonder if that would work. I'm scared to try that, to be honest, because that was such a complete mess. I don't know. What do you think, guys? Let me just have a quick break here to rest my voice as well. Okay, what do you think? Should we try EIGRP and static route redistribution again? Let's see. So enable show IP route. Let me see the situation now. And yeah, we removed the EIGRP configuration entirely. So show IP EIGRP neighbor. Yeah. Okay. Let's see here. So if we want to reconfigure EIGRP, we could do it this way. And then let's see. Redistribute static. Let me actually check the details for that command. I just want to make sure something about the metric. And we can talk more about the metric shortly. So let's see, under here. So if we try to find, actually let's just do a search, redistribute. And we want, where's the document for EIGRP? Redistribute EIGRP? What? No, that's not really what I wanted. No. Redistribute. Okay, no, redistribute static separately. No, that's not what I'm looking for. Okay, I guess risk it for the biscuit. Let's try the redistribution again and EIGRP configuration. So let me just enable the EIGRP neighbors first. I have a bad feeling about this, but let's see. Okay, so now the neighborship is up. And let me see right here. Let's just make sure we don't have anything in the topology right now. Well, other than this network, the directly connected network, because we've enabled it or enabled EIGRP on it with the network command. So yeah, that makes sense. That should be there. And let's see here as well, we should see the same thing. Yes. Okay, let's look at the IP routing table as well. Okay, so now redistribute static. Let me just try it this way first without even considering the metric. I kind of want to close my eyes for hitting enter. Okay, so let's see if anything even happened here right now. Okay, we see them here now. Okay. So they are in the topology table for R2. So let's see, are they here as well? Yeah, so now it says again that something about the infinity. So now this is what originally like threw me off. That it states here infinity. But now before I start playing with the metric or anything like that, let me see if I can change the administrative distance on EIGRP for the external routes. So let's see, I do not remember how to change that, so we'll just have to try to find it here in the configuration or with the help tool. So distance, right here, define an administrative distance. So let's go distance, set route administrative distance, EIGRP, set distance for internal and external routes. Okay, so we want to go that way because we want the external paths. So for internal routes, distance for internal routes, so you define that first. We'll keep it at 90, which is the default. Distance for external routes, we'll put that as 100 because if I go back to this document again, so OSPF has a default administrative distance of 110. So we want the EIGRP external administrative distance to be lower, so I'm just making it equal with the IGRP administrative distance. I don't think it should matter, but then again, weird things can happen. So in case we still see something strange going on, I might come back and change it to like 95 or something and make sure it doesn't overlap with any other values, or it doesn't match with the other values. Or actually, let's do it that way just now. I don't want any other factors in this mess. So yeah, let's not actually put it as 100, which is equal to IGRP. So let's just put it at 95. Let's go with that. And just in case, let's clear the EIGRP neighbors. Oh, it's I think it may have. Oh, it looked like it refreshed it anyway when I changed the administrative distance. It says the adjacency went down and then it came back up. So, okay. Show IP, EIGRP, topology. Okay, these are here now. And if you can see, this has changed to a value. So I guess these are valid now. So let's see the routing table. Okay, now they're installed as EIGRP external routes. Okay, now it makes sense. Okay, let me just try to collect my thoughts here. Like what happened previously is still in my mind, and that didn't make much sense because if you remember, those were also internal EIGRP routes, although they were redistributed with a command that was not even in the configuration anymore. So that was too crazy. I don't know. But anyway, now we're seeing what we want to. So you can see here the administrative distance, and this is the metric. So that matches what we have here actually. So now, because of the lower administrative distance value, these EIGRP external routes are installed instead of the OSPF external routes. So if we look at show IP OSPF database, so let's have a look here. You can see that those routes are still learned and they are in the OSPF database. But once again, now the EIGRP routes are installed into the routing table. And the key factor here is the lower administrative distance value. But unfortunately, I don't think we can see the OSPF administrative distance value. Well, I mean, we can see it here in the other routes. It's 110. Okay, is that clear to everyone? Let's see. Okay. Yeah, we went ahead with the route redistribution, and this time it worked. So apparently it had something to do with the administrative distance command before. I don't know, maybe that's why the metric was set to infinity. Where was that output? Let me go back to it, right here. So maybe that's why. Again, I don't remember redistribution well enough to know exactly what happens. But based on this output, I'm guessing because the administrative distance was originally higher, so it was 170, and we also had OSPF routes with administrative distance of 110, which were more preferred. So I guess EIGRP made this route invalid and ineligible to be installed into the routing table by setting the metric to infinity. This is my guess, but I don't know exactly. And then once we changed the administrative distance, so this was the command, and again I played it safe. Originally I wanted to change it to 100, but that matches with the IGRP default administrative value, so I just decided to choose 95. And after we have done that, so the EIGRP neighborship or the adjacency actually automatically went down and then came back up. And after that process was complete, then there was a valid metric and the routes were installed into the routing table and they replaced the original OSPF routes. This is my summary and explanation of what we've just witnessed here, what has happened. Any thoughts from chat? Feel free to share your comments. Nothing? Anyway, that was a very long discussion about the administrative distance, but I hope it's all clear now, and especially because the lab seems to work as it's supposed to now. So I guess we can move ahead to the metric discussion. So let's go back to the document here. So this is the final component. that we want to talk about. So metric is actually something that decides what route is best within a routing protocol. So let's say inside OSPF, for example, if the same exact route, again, the same network and prefix, is learned from two different neighbors, for example, then the one with the lower metric is considered the best route. So if we go back to the drawing board, so let's see here. So we can still use the same example. So the 192 network. Okay. So let's say that was learned, or R5 learns it from R1 and then from R4. I know we haven't configured anything on R5, but we're just talking about the concept here. So let's say from here it's learned with the metric of 20, and then here with the metric of 40, for example. So then because of the lower value, this would be preferred within OSPF. And then this is actually the route that it would install into the routing table, provided that there aren't, or the same route is not learned via other routing protocols or other sources that could replace it because of the administrative distance value. So does that make sense? We can try to demonstrate that as well on our lab here, but I'm trying to figure out which way to best do it. So we would need the, oh yeah, we would need to advertise the same network from two different paths, so they could have a different metric, and then see which one the router would pick. Let me see, we can, we can actually configure, yeah, okay, this is one way we could do it. So we could configure the same routes, or one of them, it doesn't have to be all, on R5 and enable EIGRP between them, or OSPF, it doesn't matter. And then we'll advertise that network from here and possibly change the metric, because, for example, if we use OSPF, by default the metric will probably be the same, so they're going to look like equal routes. So then they would actually both be installed into the routing table. We can actually look at both cases maybe, so you can see the difference. So maybe we'll try to do that. So we'll actually advertise a network from R5 and R2 towards R1. And now we're really doing everything like artificially, because we're using the static routes that are pointing to the null-zero interface. So this is most definitely not a realistic scenario, but this is just to demonstrate the concepts. But maybe we'll use OSPF because that's perhaps slightly more, or a little bit easier to manipulate. And also because of that hassle with EIGRP, I don't really want to touch it too much. Yeah, so let's go to R5. Let's see what we even have configured here. Show IP interface brief. Okay, the IP addressing is configured. That's good. So, if we want to do or if we want to enable OSPF, so router OSPF, and then network. Actually, I need to check what areas I've configured here. That needs to match. So, show IP protocols, for example. Let's see. Oh, looks like everything here is in area 1. Okay. So that command actually covers the entire range. So for 10.10 and then everything else, anything else for the 2 octets is going to be in area 1. So I don't have to add anything on R1, but here I can do 10.10.45.0 and then area 1. And this should work, hopefully. And actually I put the wrong one. I put the network between 4 and 5, my bad. It's 1 and 5. This way. Of course, if we have it configured here. Ah, yes, there it is. Okay, so OSPF neighbor. So you see that R5 and R2 are now neighbors with R1. So then now we can do more static routes and redistribution and hope we don't mess anything up again. So let's have a look here. Show IP route. Oh yeah, but now we have the EIGRP routes here. Okay, let me see if I want to yeah, I might have to remove the EIGRP configuration so we can get the static routes into the routing table via OSPF again. Unless I want to advertise something else from here, that could also work. I could do, actually we don't necessarily need to touch these right now, but I could make a crazy scenario because I see that R2's loopback address is advertised. So we could configure a static route pointing to the null 0 interface again on R5, or we could even configure this on R5 as a loopback interface, just so we can advertise it 1 hop away, similarly to R2 here. Like, do you understand what I'm trying to do here? So I want to advertise maybe this network, which is like 1 hop away from R1 right now. So then coming from this direction, and then it would be 1 hop away coming from this direction as well. So there's like really 2 ways I can do it if I want to use redistribution. I can configure it as a static route here on R5, or even configure it as a loopback interface. Once again, you do not want to configure anything in production in this way. This is just simply to understand the routing principles and the concepts. Like, this is a completely ridiculous configuration otherwise. But my point is just that we advertise the same hop, the same route, which is only 1 hop away So, and then after that we can manipulate the metric and you can see what happens inside OSPF. Maybe I could just configure it as a loopback interface, and then we can use the network command and we don't have to use redistribution to advertise that. So maybe I'll try it that way. Let's try that. And also if I do it that way, then it's like more equal to the configuration on R2, although again you would not want the same network configured on two routers like that. So let's try it that way. So let's do loopback 0. So IP address 2.2.2.2, and this is /32. Okay, so do show IP interface brief. Okay, so then right now if we go back to OSPF and we do the network command, let's be very specific with the 0 mask and area 1. So now this this enables OSPF on that interface, so it will be advertised via OSPF. So let's have a look here. And yes, this is exactly what I wanted to see. So now these routes are considered equal. So you see that this network is available via both R5 and R2. And the metric here is 2. So now we can try to manipulate the metric. But actually before I do that, let's look at this in the OSPF database. Let's have a no. I wanted to look at the I forget what it is now. Database. Is it network? No. Let me see, internal. Actually, I don't think it's like that. My bad. I forget what command I'm looking for. Advertising router summary, database summary, no. Let me have a look here. Router, this one first. Yeah, okay, so this is what I wanted to see. So this is what R2 is advertising, or this shows like the connected networks on R2. So let's see if we do the same on R5. So we can see that same information here. Yes, this is what I wanted to look at. I forgot the command I was looking for. So now let's see. So we want to change the metric. So let me see what there's probably many ways that we can do that, but I'm trying to figure out the easiest way to demonstrate this. Can we do maybe on R5 if we do, is there like a neighbor? No. Neighbor, can we specify it here maybe? OSPF cost for point to multipoint neighbor. No, that's not what I want. No. One way we can do this, actually, this might be the easiest. If we go under the interface, loopback 0, and then let's see. I wonder what the command is. Is it cost? No, IP OSPF. So technically there's two ways that we could change the metric on this interface. So we can change the cost, so we can specify a value for that, or we can change the bandwidth and then OSPF will calculate a new value for the OSPF metric. But I believe this is just much easier to do, and also the bandwidth is used for other things, so we shouldn't really touch that. So let's do cost, and let's see. Let's just do like, I don't know, 55. So because it's coming from router 5. So that should change the cost of this link to 55. So let's see, I might have to refresh the adjacency, but let's just quickly go back here. So let me have a look. Yeah, let's refresh here. So clear IP OSPF neighbor, or clear IP OSPF. Is it that? I really do not remember these commands. Or is it star? No. IP OSPF 1. No. Process. Clear IP OSPF process. Yes. My brain is running slow right now. I think the mess with EIGRP redistribution is, I don't know, it destroyed my brain cells. I can't think right now. Alright, so let's see. Let's see what happened to our routing table right now. Show IP route. Okay, you see that now there's only one route, and this is pointing to R2. You can see from the next hop. So let's look at the show IP OSPF database again. And no, actually, no, that was not the command that we needed. We need the more specific one. So this is what's coming from R2. And then let's see on R5. And now here is the metric that we configured when we changed the cost value. So you see now that this is less preferred because it has a higher metric than this one right here. Does that make sense? Any questions? Sorry, I haven't been looking at the comments right now. Well done. Yes, thank you. This has been wonderful so far. Okay, so what do we even have in the routing table now? Okay, so this one that we manipulated in a crazy way, we also advertised this from R5, that is not in the routing table right now because it has a higher metric. So R1 has selected the path towards R2. But as you've seen, it's still learned via OSPF, so it's in the OSPF database anyway, but not in the routing table. And then we had this crazy EIGRP external routes here. And one more time, they are preferred because of the administrative distance. So because we changed it to 95 from the default value of 170. So actually let's look at that one more time. So those routes should still be in the OSPF database as well. So show IP OSPF database. And indeed they are. They are right here. And here is the show IP EIGRP topology. So the same routes are here also. Okay. Let me have a quick break again. Okay, let me go back to the document here. This route selection document. Let's see what else is on here, or if I can summarize everything that we've discussed over like nearly 2 hours that I've been live streaming. Let's have a quick look here. Oh, this also talks about backup routes. I guess this is referring to the floating static routes. Possibly. Or adjusting the administrative distance. Well, this is actually something we have done already. And here it talks about the defining or how metrics determine the route selection process. Okay. Then the prefix length. And then making forwarding decisions. So I guess this document goes over some examples as well. We can look at that in more detail shortly. Or maybe there's a nice summary here. Let's have a look at the last section. So in summary, making a forwarding decision actually consists of 3 sets of processes: the routing protocols, the routing table, and the actual process which makes a forwarding decision and switches packets. These 3 sets of processes are illustrated along with the relationship below. Okay, so first there's the routing process. So install routes winner based on administrative distance. That goes into the routing table, then find the longest prefix match, and then it goes to the forwarding process and the packet is forwarded according to that decision process. And then finally here it says the longest prefix match always wins among the routes actually installed in the routing table, while the routing protocol with the lowest administrative distance always wins when installing routes into the routing table. Okay, so let me go back up to the top here. So this is really, or let me backtrack to summarize how I like to think about this myself. So the administrative distance is the component that decides what route is installed into the routing table between different routing protocols or route sources. But once again, keep in mind that this is for the exact same prefix, or the network and prefix length combination. Now the metric decides inside the routing protocol which one is the best route if the same route is learned from multiple neighbors, for example. And then the prefix length is what decides how the packet is actually forwarded. So the most specific or the longest prefix match is used to forward the packet. Does that make sense? Any questions? No, I don't see anything. So if I go back to the topology and maybe if I try to draw something here again. So as we've seen here, so basically there are these tables in the router. So there's one for EIGRP. This is the topology table that we've looked at. And then we had OSPF. Oops. So, oh, and then let's put the routing table here. Route table. So now when, so EIGRP has like a bunch of routes here. Let's see. Net. Can't really fit much text in here. But yeah, a bunch of routes here. And the same in OSPF. So actually, or we can even consider like one route in this case. So let's say, let's put some arbitrary metrics in here. So let's say like 100, for example, and then 1000. And for OSPF, it doesn't matter which values we really use, 50 and 500. So now in this case, inside the routing protocol, this metric value is used to decide which one is the best route. So of course the lower value is considered better. So now these routes would be, how can I say, like offered to be installed to the routing table. So OSPF says, hey, this is my best route, this one with metric 50. And then EIGRP says the same thing. This is my best route with the metric 100. But these metrics are not directly comparable because each routing protocol uses a different metric. So you can't really compare those values. Even though here it looks like you could because I just gave them like arbitrary numbers. But this is something related to the algorithm that produces the metric. So they are not comparable. So you can't compare these values directly. So this is why you need the administrative distance. So now these routing protocols, they offer these routes to the routing table, but then we have to consider the administrative distance value. And if we think about these as internal routes, so by default the default 80 for EIGRP is 90 and for OSPF it's 110. So this is going to win. So then this route gets put into the routing table. So let me just put this net here and whatever 100. Like so. Now the routing table is populated by the best routes from different sources. So you can consider the routing table like the best of the best that end up there. And now in the routing table, if we have those routes like I introduced in the beginning of this session. So we can try to type them here again. So like 192.168.1.0 and /24. 168.1.0/25. And then we have the third one. I can try to squeeze that in here as well. I don't know what my pen tool is doing again. That's kind of terrible writing, but we'll just go with it. So now these are all unique routes and they would be included in the routing table. But the actual forwarding process is based on the most specific match. So this really depends on the destination IP. So destination IP, and then most specific route is selected, or longest prefix match. And yeah, this really, the destination IP really defines how it will be forwarded. So if we have something that falls under or is in the range of 0 or 1 to like 126, then it would be forwarded according to this route. And actually in this case it's funny. So technically the /24 route would not be used to forward any traffic in this case. Why is that? Well, because these two other routes actually cover the entire range. So the first one covers from 0 to 127, and this one from 128 to 255. So if we have, let's say, 192.168.1. I don't know, 57, that would fall under the first route. But if we had, let's say, 132, that would fall under the second route. Does that make sense? Any questions? No questions, just a couple of emojis there. All right. So I guess we've more or less covered the route selection now. We certainly took a long time to do that. Let me just remove this beautiful drawing and actually close this. So if you want to go through the document, I'm pretty sure there were some examples towards the end here. Let's have a look here. So yeah, I guess this section described that. So all these unique routes, which are overlapping, like if you see here, this one is /19, /24/26, but the base network address is the same all the way. So now, depending on the destination IP address, this the packet would be forwarded differently. So let's actually look at this quickly. So if a packet arrives on a router interface destined for 192.168.32.1, which route would the router choose? Actually, you can try to answer this question before you want to look at the answer. Okay, so it depends on the prefix length or the number of bits set in the subnet mask. Longer prefixes are always preferred over shorter ones when forwarding a packet. So in this case, it should use the EIG IP route because that has the longest prefix match. So let's see, in this case, a packet destined to 192.168.32.1 is directed toward 10.1.1.1 because 192.168.32.1 falls within the /26 network. It also falls within the other two routes available, but the /26 has the longest prefix within the routing table. So yeah, this document goes over a couple of examples if you want to read through this. Yeah, so we've definitely covered this whole thing in way more detail than I originally intended, and ran into some issues as well. A couple of interesting behaviors. So let me see, what else did I want to cover? Oh yeah, I wanted to talk about the routing principles. I don't have a link for that yet, so let me just Google what I mean. So these are like routing principles by, I think it's Alex Zinin, if I'm pronouncing that correctly. So these are from the book Cisco IP Routing. But I just want to show you the principles. So let's just take a look at this one, for example, from a blog called Cisco e-learning. So I guess yes, these three principles right here. Maybe I'll try to zoom in a little bit. So here it says, number one, every router makes its decision alone based on the information it has in its own routing table. Number two, the fact that one router has certain information in its routing table does not mean that other routers have the same information. And number three, routing information about a path from one network to another does not provide routing information about the reverse or return path. So these are really important concepts to remember, and these come in handy, especially when you're doing troubleshooting, like when you can't ping something. So it's useful to look at the entire path and understand how these principles work. I'm trying to think of a way to maybe explain this without it getting too convoluted like our previous demonstrations with the route selection. Okay, so let me try to talk about the first principle. So every router makes its decision alone based on the information it has in its own routing table. So let's say if we go to R1, for example, show IP route. So again, this is a map on the router or a collection of the best routes that the router uses for packet forwarding. So now this is the information the router has, and this is the information that it uses to make routing decisions. So it does not know what its neighbors, in this case R2 and R5, what they know. R1 is not aware of that. It only knows what is in its own routing table. And all the routing decisions and path forwarding is based on that information. So that's essentially what the first routing principle means. And the second point, so the fact that one router has certain information in its routing table does not mean that other routers have the same information. So once again, if we go back to R1, the fact that R1 has a certain route in its routing table, let's see, what could we pick here? Let's say this one, like R4's loopback address, for example. That does not mean that other routers on the path to R4 have that same information. So for example, if we go to the topology, so here for R1 to get to R4, it would have to go either through R2 and R3 or through R5, although we have not configured a neighbor relationship between R5 and R4, so OSPF is not enabled, so that wouldn't work in this case. But the point is that just because just because R1 has the routing information for how to reach R4, it does not mean that the other routers on the path know about it, or that information is in their routing table. For example, we could do some crazy tricks, although I don't know if I want to get into that because it gets a little bit complicated. But for example, there could be a situation where that route, so R4's loopback address, is advertised all the way to R1, but for example, it's not installed into the routing table on R2. So then that's exactly where the second principle comes in. Just because R1 knows about it doesn't mean that the other routers have the same information. So R2 or R3 might not know how to reach R4 for whatever reason. But I don't know if I want to demonstrate that during this session, especially with OSPF, because the route advertisement is based on the database exchange and the routing information is exchanged via LSAs. So it's a little bit different from EIGRP, which is kind of like routing by rumors, or it only learns routes from its neighbor or what the neighbor tells it, and it doesn't have full topological information like OSPF does. So maybe we won't get into that during this session. And let's see the final principle. So number 3 again, routing information about a path from one network to another does not provide routing information about the reverse or return path. Yes, I feel like this ties together with the previous point a little bit. So just because R1 has a route to R4, for example, it does not mean that R1 knows, or excuse me, R4 knows how to send the packet back to R5. To R1. I'm confusing the numbers so badly right now. So just because you can go this way doesn't mean that you know how to come back. So that is completely different. And once again, because routing by default is destination IP based. So when we send a packet from R1 to R4, the destination IP address would be this. But then when the reply packet is sent back towards R1, the destination IP address is now of R1. So of course the routers on the path, they're not looking at the same IP address even anymore, if that makes sense. And actually by I misspoke there a little bit because I said the source address or the destination IP address for the return packet would be this one. But actually by default it is the IP address of the exit interface. So depending on which way we went, but I'm speaking as if R5 is not in play right now, so it would be the IP address of gig 0/0 in this case. So yeah, that's the thing about the routing principles that you have to keep in mind. So you can't just look at the routing table on like a random device somewhere in the topology and then decide from that whether the ping or packet forwarding should work. Like there are multiple factors that you need to configure, and you need to understand those principles. So I hope that makes sense. Any questions? No, I don't see anything at the moment. Let me just see. Yeah, okay, so we definitely covered the route selection process in a lot of detail. And now we talked about the routing principles. I haven't really demonstrated that, and I don't know if I should get into that in this session because we've already been going for a while, and maybe I would want to think a little bit ahead how to demonstrate that. Chat, what do you think? What do you think? Any suggestions? Is there anything you want to see? Or is anyone watching? I might be talking to myself. I don't know. Oh, hello. Okay, we have someone still online. Thank you for joining. Do you have any questions or like anything else you would like to see? I'm kind of trying to figure out what I would still want to show you. I don't want things to get too complicated and possibly run into more issues like with the EIGRP route redistribution earlier during the session. So I'm thinking if there's something to present here. Multi-area OSPF? Okay. Is there anything specific you would like to know about that? But again, I probably don't want to go into too much detail because that can be a session on its own. But if there's something quick you want to look at, maybe I can try to figure it out. One thing I can say about multi-area OSPF is about the route preference, although that is another very complicated subject, so I don't want to get into it too much. But if we just talk about it on a very basic and general level, then of course intra-area routes, so routes within the area, are always preferred over inter-area routes. So like in this case, so I have actually multiple areas configured here. I don't remember exactly how, like we looked at this earlier. EIGRP, excuse me, R1 is in area 1, so show IP protocols. This is a pretty quick way to look at this. So you see here we're routing for these networks and they're both in area 1. I guess we can look at the same on R2. So show IP protocols. Yeah, okay, so here we actually have the backbone area, area 0 and area 1. So here we can see 2 areas, so this, yeah, it's a multi-area network. Actually, how I can tie it together with what we've discussed during the session so far, because we talked about the administrative distance and the metric and the unique prefixes. So I suppose one thing that I could describe briefly is that if you somehow learn the exact same route inside the OSPF area, so it's an inter or intra-area route, and then you also learn the same route as an inter-area route, and oh my god, I'm sorry, my brain is slow and I'm finding it hard to focus. Maybe it's easier if I draw it here. So I guess what we have currently, from what I could tell from the configuration, so we had something like this, like these are in area 1, and then here we have area 0. Area 0. So now, if somehow the same exact route, and again we can use the same example we had before. So once again, the 192.168.1.0/24. So if it was learned as an intra-area route, so this is the O route, or inter-area. So the OIA route. And let's say that this one actually had lower metric, so let's say 10. Because we talked about this, like within the routing protocol, the metric determines the best route. So let's say the intra-area route had a metric of 20. However, in this case, that actually doesn't apply, because OSPF always prefers intra-area routes, regardless of the metric. But once again, like, this is a great question that you asked about multi-area OSPF, but this gets very complicated. Like, OSPF route selection is one of the most difficult topics that I know. Like when you actually start looking at it. So there's this great blog post. So let me see if I can find it. Actually, I can remove this drawing as well. So OSPF route selection. Let me see. I think it's an INE blog, or this talked about only the external path selection. I thought it discussed the internal routes as well, or intra and inter. But yes, this is one excellent document if you want to take a look at it. But a disclaimer, let me warn you beforehand, this is very detailed, very complicated. So, well, here is actually a very quick summary. So regardless of a route's metric or administrative distance, OSPF will choose routes in the following order. So as I mentioned, intra-area routes are always preferred over inter-area routes. But once we move on to E1 and E2 or N1 and N2 routes, it gets more complicated. And I don't want to cover that in this video, but if you are interested, you can take a look at this. But yeah, a word of warning, you need to pay attention here. It gets very complicated. But yeah, if you're interested, go take a look at this blog post. As you can see, there's quite a lot of information here as well. I can like copy this as well and put it in chat if you want to see it yourself. But this is definitely something for another time. So let me X out of these. But yeah, I think that's enough information for this session. So unless anyone has any other questions or comments, I will probably end the stream shortly. I'll give a few moments. All right, Danny, I appreciate it. Thank you for joining the session. I hope you learned something new here and also from the blog post that I linked. Yeah, I'll just hang out here for a few moments, but I'm gonna log off soon, so if you still have anything to add or any more questions or comments, like feel free to share in chat. Nothing, I don't see much more going on in chat. So yeah, we can probably end the stream. Scaling MPLS, a suggestion there. Yeah, that we could maybe do for another session. I'm not too familiar with MPLS, or it's not my strongest topic, so I might have to hold off on that one for a while. And BGP, yeah, we can definitely do BGP topics. Is there anything specific that you would like to see? My previous live stream was about AS path manipulations. I introduced a couple of commands from the CCIE Enterprise Infrastructure Blueprint. So you can go look at that video if you like. It's still available on my channel. But is there anything specific about PGP that you wanted to know? Route filtering in PGP. Okay. Yeah, we can do that. Definitely. That can be one topic. There's actually like many topics in PGP that I need to cover. So I have the blueprint here. So this is what I'm using as my main study resource to make sure that I've covered all the topics in the exam, and also this is good for tracking your progress. But yeah, PGP is a big topic in this exam, and there's many things to cover here. This is a big one, PGP path selection, talking about the attributes and the best path selection algorithm. Yeah, attribute manipulation, conditional advertisement, outbound route filtering. Yeah, you pretty much mentioned this. You're talking about PGP route filtering. This is what I covered last time in my live session. So local AS, allow AS in, remove private AS. And actually, this is just one part of the PGP topics in the exam. So there's actually this general section for routing concepts, and this applies to all routing protocols. So if you look at this, there's like route filtering with any routing protocol, summarization, redistribution. Well, we got a hint of that today with interesting results. And then there's routing protocol authentication. So yes, these topics are probably coming. I don't know in what order, but yes. What else? Preventing route leaks in PGP. Okay. Kindly share the link you are on here. Oh, this is the CCIE Enterprise Infrastructure Blueprint. Yes, I can certainly put that in chat as well. There you go. This is a very, very long list. I was only under the network infrastructure section here. So this covers the routing protocols and some switching and stuff like that. But there's way more here. This is only 30% of the exam. Here's like SD-WAN, SD access. Then what else do we have here? Yeah, MPLS and DMVPN. And then some security topics. Even this is a long list. And then some automation and programmability. So yeah, there's plenty to learn and study here. So I will try to do more of these study sessions. So what we covered today, actually, it's not really specific to this exam blueprint, because we talked about the basic routing principles and route selection. But for example, administrative distance we covered, and static routing to some extent. There's still some other things about static routing that could have covered, like the floating static route. And actually about administrative distance, did it mention it on this table? It does not say here, but I believe the administrative distance 255, that's considered invalid. So if you have a route with that administrative distance, it will not be installed into the routing table. We could actually test that really quick now that I remembered it. I hadn't considered this before. So let me see. How can we even define this? I don't remember. So if we do a completely separate route, we can do something else like IP route 172.16.0.0, for example, and 255, something like that. Did I type something wrong? IP route. Yeah, there we go. Yeah, I still want it to the null zero interface. But here, yeah, you see you can define the administrative distance for the route separately. So if we put this as 255, I think this should be invalid. So this should not be put into the routing table, but let's have a look. So do show IP route, and let's do static. Yeah, you see it is not here. So let's say if we change that. So let's do let's remove it. So no IP route. And then let's do it again, but let's change it to 254, for example. So it's one lower than before. And if I'm correct, it should appear in the routing table now. So yes, now it's been installed into the routing table. So that's actually a good thing to remember. A comment, will this live session be available for viewing later? Yes, it will be. I will keep it public so you can watch it later if you want. Thank you for joining anyway. I'm about to end the stream shortly, but I keep getting sidetracked. But yes, you can find this video available after I end the stream. Yeah, that was actually a good thing to note about the administrative distance. I didn't realize to mention this before, because I don't think it states that anywhere here in the document. I think the range was mentioned somewhere, or maybe it was in the command reference that we looked at. I can't remember. I don't see it here. But anyway, the range is from 1 to 255. Like if you look at the command line help here, it tells you the range, but it does not say that 255 is actually invalid. So if you set it as 255, it's not installed into the routing table. You see that this is empty. So only after we remove that route and configured it again with 254, now it's in the routing table. Yeah. Okay. One more time, are there any questions? If not, then I will end the stream here. I'll wait a few moments because I think there's a bit of a lag, or there's a bit of a delay from my streaming software to the live stream itself. So that's why I don't always see your comments on time, or I see them a little bit late. Okay, I don't see anything. Okay, well, thank you to everyone who joined the live stream and who are still watching at this point. I think we've been live for nearly 2.5 hours. And as mentioned, the video will be available, so if you want to watch this later, feel free to do so. Yeah, I don't know if this will be available immediately. I don't know if YouTube has to process the video somehow, but I will definitely keep it public for later viewing. So, yeah. Thank you again for joining and watching. So, I'll see you next time. I'm going to end the stream here now. All right. Bye-bye.